Okay, good evening, all of you. Today we are going to discuss about the second lesson of heat calorimetry. In our first class, we have discussed about the structure of material, then the nature of particles, then about absolute zero. After that, we have discussed about the total internal energy. Then about heat. No, what is a heat? Then what will happen to an object when heat is applied? Okay, those are the things we have discussed up to now. Okay, do you have any questions regarding that? Or we can summarize the first lesson. Okay. According to our previous lesson, the first thing we have discussed was the structure of matter. The structure of matter. According to that explanation, the matter is made up of particles. Particles, the structure of matter. Matters are made up of particles. Then those particles are bound together by intermolecular bonds. So, depending on the strength of intermolecular bonds, there are three types of states. What are those? Answers, Digna.
Solid, liquid, and gas.
Very good, very good. Okay. Okay. In solid, the intermolecular bonds, the strength of intermolecular bonds is strong. Then in liquid, it is relatively low, may compare with solid. Then, when it's come to gas, the intermolecular bonds can be negated, no? It's very weak intermolecular bonds. Okay. Then we have discussed about nature of the particles. Under that topic, we have discussed if there is an object other than absolute zero, that particles normally they have a movement. Normally. They have a vibration as well as they are bounded by intermolecular bonds. They are bounded by intermolecular bonds. They are bounded by intermolecular bonds. And those particles have vibrations at temperatures other than absolute zero. They have a vibration or movement. Movement can be happen. When it comes to gas particles, most of the gas particles can move here and there. Therefore, in gas particles, there is a movement. Okay. Then there are intermolecular bonds, intermolecular attractions force between those particles. Okay, those are the characteristics of the particles the matter is made up of. Then we have discussed about after discussing the absolute zero, then we have discussed about total internal energy. What is the internal energy? What is the internal energy? Can anyone tell me? What is the internal energy? What does that mean? Internal energy?
The sum of the kinetic energy and potential energy of particles?
Yes, very good for that. Very good. Okay. Due to this vibration, that means as per our previous discussion, they have vibrations. So due to this vibration, definitely, obviously, they should have kinetic energy. Then, due to this attraction force, they have a potential energy. They have a potential energy because we need to supply energy. We need to supply an energy to remove this particle. To remove this particle, we have to supply an energy to break those intermolecular bonds. Therefore, we have to do some work. Against this attraction force. So, if we have to do a work, please listen to me very carefully. If we have to do a work against the attraction force, if we have to do a work against an attraction force to move some object, then that energy is called as a potential energy. Okay. So if we have to do a work to move against an attraction force to move some object or particle, then that energy is a potential energy. Okay. So mg normally when you hear the name of potential energy, you remember this equation, no? This is one of potential energies. Okay, this is called as gravitational potential energy. So if we move a particle against the gravitational attraction force, that required energy is called as gravitational potential energy. That is equal to mgh. Okay. If you move more charge, not a particle, more charge against an electric field, it called as electric potential energy. I think you remember this one. V equal IR equation. What is this one?
Voltage.
Voltage or potential difference. Normally we call as potential difference. We means potential difference. Potential difference means this is energy difference. Okay. We call it as volt because it is in electric field. So this one also a potential energy. Is a electric potential energy. Okay. Therefore, when it comes to potential energy, this is one of potential energy type. This is a one type of potential energy. Okay. So it is not limited to mgh. Okay. So definition means if we move an object against the attraction force, we need the energy. That energy is called as a potential energy. That attraction force may be a gravitational attraction force, maybe electric attraction force, maybe a magnetic attraction force, any kind of attraction force. So if we move an object against an attraction force, that we should have energy. That type of energy is called as a potential energy. Okay, potential. So in this case, there are actually this is some kind of electromagnetic attraction. So in this case, there are intermolecular attraction. So if you want to remove one of these molecule or atom, we should have energy. Okay, we should supply energy. So that is against this attraction force. Therefore, it definitely should be a potential energy. Potential energy. Therefore, they have the potential energy. They have potential energy. They have kinetic energy as well as the potential energy. So the sum of kinetic energy and potential energy is called as the total internal energy of that particle. Okay. Then we have defined thermal energy or heat energy. So what is heat? What is heat? Tell me. What is heat?
Type of energy that change the internal energy of an object.
Very good. It is a type of external energy that can change the internal energy of that object. No? Yes. Yes. Very good. Yes. Very good. Okay. It is a type of energy that can change the internal energy of an object. That means if we can change the internal kinetic energy or the strength of intermolecular bonds using an external factor, that factor is a heat. Okay. Then we have discussed what happens when heat is supplied to an object. What happens when heat is applied to an object? What happens? Internal energy increases. Initially, what will happen? When heat is applied, what will happen? Suppose there is an object. There is an object. Now we are going to supply heat energy, heat or thermal energy. So once we supply heat energy or thermal energy to this object, what will happen first? Initially, what will happen?
Kinetic energy increase.
Very good. Kinetic energy of those particles increase. Okay. At the first stage, there won't be any significant change in the potential energy or strength of intermolecular bonds. Okay. Suppose I'm holding two hands of another two persons. Okay. Now we are shaking our hands. Listen to me very carefully. Now we are shaking our hands. Okay. Suppose if this vibration, if I increase this vibration, what will happen? Still I can hold those hands. No, still I can hold those hands. But up to some level, after some point, I cannot bear the amount of vibration. No, I cannot bear that part. Then what will happen? Balls.
The bond will
Yes, bonds will be broken. Okay, but up to that level, I can bear those two hands. I can bear. Okay? Up to that level, I can bear. Therefore, up to that level, the potential energies, intermolecular bonds, will not be changed. Up to that level. But after that level, the bonds will be broken. Okay? Did you get my point?
yes.
So up to that level, Buddha, because anyone can bear the vibration up to some extent. Okay, so up to that extent, the intermolecular bonds will not be changed. That means the supplied heat the supplied heats will not be used to break intermolecular bond. So the supplied heat should be totally utilized to increase its vibration energy, that means kinetic energy. Therefore, initially the supplied heat is totally or entirely utilized to increase its kinetic energy. So according to the heat conservation law, the supplied heat at the beginning, the supplied heat should be equal to the kinetic energy increment. Did you get my point? Because any material can bear that increment of kinetic energy up to some extent. Therefore, up to that extent or up to that point, the intermolecular bonds of them will not be changed or will not be broken. Okay, therefore, the supplied heat is totally utilized to increase its kinetic energy. Did you get my point? This is very important thing. This is very important thing. Devnad?
Yes, sir.
Thank you. As I told you earlier, the first 2 or 3 weeks of heat is very important because the total heat lesson is in first 2 or 3 weeks. And first 2 or 3 weeks heat lesson. So you can explain most of the things in heat using those theories. Okay. So if anyone need further explanation, please let me know. Devnad? Further explanation only? No. So in this case, the supplied heat is totally utilized to increases of kinetic energy. All right. Then what will happen? I will explain. Now it is in the initial stage. I will explain how that happened. Okay. Okay, Buddha. Then, okay. Actually, what's the kinetic energy of those particles? Okay, I will explain. Okay. Again, look at my 2 hands. I am holding these hands with another 2 hands. Okay. Now we are vibrating our hands. Okay. Now we are vibrating our hands. Still, we can hold our hand. Now we will increase our vibration speed. But still we can hold our hand. Therefore, this bond, that means we can bear our hand, we can bear our 2 hands, we can hold our 2 hands up to some extent, no? But if we increase the vibration speed further, then there will be some point we cannot hold our hand further. Then what will happen? Then the bonds between us will be broken. But up to that level, we can bear our hands. That means the intermolecular bonds won't change up to that level. Therefore, the supplied heat is totally used to increase its kinetic energy, not the potential energy. Okay. But after that level, it will be changed. Okay. But I will explain that thing later. But up to that level, the supplied heat is totally utilized to increase kinetic energy only. Okay. Okay. Now, when the kinetic energy increases, we can feel it. How can we feel it? When the kinetic energy of an object increases, yes, very good. By temperature. Okay, we can feel it by temperature. So temperature is a sensation, or it is a sensation, and it depends on the kinetic energy. When kinetic energy increases, temperature also increases. When kinetic energy goes down, temperature goes down. So temperature is a sensation that depends on kinetic energy. When the kinetic energy increases, we can feel it by the temperature of that object. The temperature of that object increases when the kinetic energy of the particle increases. This is very, very critical theory, because you have to understand this one. That means the kinetic energy of particle, actually not the kinetic energy, temperature of that object, the temperature of that object depends on kinetic energy. Okay, actual temperature. So according to that explanation, temperature is a physical quantity that reflects the magnitude of the kinetic energy. Okay, so it is not a measurement, but it reflects the magnitude of the kinetic energy. If the temperature is a higher value, that means that object has more kinetic energy. If the temperature is a low value, that object has relatively low kinetic energy. Did you get my point? Okay, thank you. Therefore, temperature is a sensation. It depends on temperature. So it depends on kinetic energy. So we can define temperature using that explanation. So temperature is actually it's kind of physical quantity. We can measure that thing. We can measure the temperature. It is a fundamental physical quantity. So temperature is a physical quantity, but it reflects the magnitude of the kinetic energy. It is not a measurement. Actually, it is not an actual measurement of kinetic energy. It is not an actual temperature. Is not an actual measurement of a kinetic energy, but it reflects the magnitude of kinetic energy. When temperature increases, kinetic energy also increases. Okay.
Sir, excuse me.
Yeah.
Sir, so that means like when the kinetic energy is increasing, the temperature of the object would increase.
Yes, that is the thing.
So, sir, in terms of latent heat, sir, like when thermal energy is supplied first, there is a change in state. That means the potential energy would be changing first, right? And then the kinetic energy.
Changing instantly.
Sorry, sir.
Changing state means that.
In latent heat, sir, without an increase
No,
in
no, no, no. Still, still, I'm not coming. Still, actually, I'm explaining this thing for a constant state condition. That means there's no change in state. Puta. There will be a change in state. I will come to that topic. Okay.
Okay,
State
okay.
is not changing state. Okay.
Okay, sir.
Now this is a constant state condition. Still, the state is a constant. Okay. I will come to the changing state condition. Okay. That's why
Okay,
I start from the beginning. That's why I start from the beginning. Once you supply heat, the first thing happen is the increment of increases of kinetic energy. Okay. Once the kinetic energy increases further, what will happen? Then there's a point the intermolecular bonds will be broken. That is the point the change of states happens. Okay, I will explain that thing. Okay, but up to that level, the state is constant. The state is constant. So there's no change in potential energy. There's no change in potential energy unless the state of matter is changed. Okay. Did you get my point?
yes, sir. Thank you.
Okay. So, do you have any other questions?
No, sir.
Okay. What about others?
No, sir.
Hey, Madam, did you get my points?
Yes.
So heat. So not heat. So temperature. If we define a temperature, it is a sensation. It depends on kinetic energy of particle. When kinetic energy of particle increases, temperature increases too. Okay, but up to that level. Okay, up to that level. I will explain that thing after that. Okay, so we can write that thing. Write a topic. Write a topic. What is a temperature? What is a temperature? Okay, I will come to the previous topic. Previous topic means what happens to object when heat is applied. No, so I will come to that the previous topic again after defining temperature. After defining temperature, because I have defined temperature to explain that thing further. Okay. So, what is temperature? Write this thing. When heat is supplied when heat is supplied to an object
Is it the seventh?
the first thing
Excuse me,
yeah,
sir, is this seventh?
sorry about that.
Is this seventh?
I cannot hear you, Mr.
Sir, is this the seventh question? We have written one so far. Question seventh one.
Still, I cannot hear you. Your sound is not clear. That's a problem. So this is another topic, Putha. My topic is what is temperature? What is temperature? So under that topic, you have to write that thing. Actually, we were discussing about what happens when heat is applied to an object, no? So that is that was discussed in our previous class. But this is another topic. What is temperature? So on that topic, you have to write the thing. When heat is applied to an object, the first thing happen is the first thing happen is increment of kinetic energy, of the particles. The change in kinetic energy, of particles is sense externally, is sensed externally as a change in temperature, as a change in temperature, as a change in temperature of the object. Write in another paragraph. කොටු කරන්න බලාගෙන මොනවද ගන්න. Therefore, temperature is sorry. The previous the entire sentence no, the change in kinetic energy. The change in kinetic energy of particles is sense is sensed externally, is sensed externally as a change in temperature of the object. Okay. Write in another paragraph. Therefore, temperature is an external sensation temperature is an external sensation that depends on the kinetic energy of inner particles.
Excuse me, sir.
Yeah.
That depends on.
The kinetic energy of inner particles.
Okay.
Kinetic energy of inner particles. Yeah, for temperature. It is directly proportional to kinetic energy of particles. Kinetic energy of particles. මේක කොටු කරගන්න. ඔය කොටු කරගන්න. මේක අතිශය වැදගත්. Explaining Buddha, that means okay. This one, temperature is an external sensation that depends on kinetic energy of inner particles. That means when you supply heat to an object, you can clearly see the increases of temperature. No? Temperature increases. No? When you supply heat energy to an object, its temperature increases. Okay. According to our previous explanation, when you supply energy to an object, what will happen first? Its kinetic energy increases, no? Kinetic energy increases. Therefore, the temperature should depend on the kinetic energy, no? Because when kinetic energy changes, temperature changes. Okay. So temperature is an external sensation that depends on the kinetic energy of an object. Okay. Did you get my point, everyone? Others? History?
Okay, sir.
Because initially you ඔයගොල්ලෝ ඔක්කොම හොඳට දෙන්න ඊට පස්සේ ඉතුරු කැලලත් එක්ක okay. I may you will understand clearly this thing after explanation of other part. Okay, I will explain that thing. But up to now, if there is no any phase difference or state difference, state changes, when we supply heat to an object, its temperature increases with heat, no? With heat. According to my previous explanation, when heat is applied, the kinetic energy increases. And also temperature increases. That means when kinetic energy increases, temperature increases. When kinetic energy increases, temperature increases. So that means temperature depends on kinetic energy. Temperature depends on kinetic energy. Therefore, we can define temperature as a external sensation that depends on the kinetic energy of particles. Okay. Alright. Then we can go to the previous topic again. What is the previous topic? What is the previous topic, Putha?
What happens when heat is applied to an object?
Yes. But before that, we can write the difference between heat and temperature. Heat and temperature. So what is the heat? What is heat? It is heat is an energy that can change the internal energy of an object. Heat is an energy. You have to underline that thing. Heat is an energy. It is an energy. Heat is an energy that can change the internal energy of an object. But temperature is a sensation. It is a sensation. So it is a sensation. That depends on kinetic energy of inner particle. Kinetic energy of inner particle. Okay. Did you get my point? තේරුණාද? තේරුණාද?
Yes.
එහෙනම් ටක් ගාලා මේ table එක ගහන්න. So please draw this table quickly. Okay. Shall I clean the board? No objections, no? Okay. Then again, try the previous topic. What is the previous topic? What happens when heat is applied? When what happens when heat is applied to an object? What happens when heat is applied to an object? Okay. Actually, we were in the middle of this lesson, no? But after that we had to define temperature. Okay. That's why I stop temporarily. Then again we can go to that part. Okay. What happened? What happens? When heat is applied to an object, the first thing happen is increases of kinetic energy. Kinetic energy increases. No. Suppose again, look, please, everyone, please look at the board. Everyone, please look at the board. Okay. Please consider this example, the previous example. Suppose I'm holding two other hands and we are vibrating our hands. No. So if I increase the vibration speed, if I increase the speed of vibration, what will happen? Still we can bear our hands. Still we can bear this vibration. So we can increase the speed of vibration up to some extent, up to some point. No? So once we reach to that point, then what will happen? Once we reach that point, that means now we increase the speed of vibration further. So once that point is reached, what will happen? Now we cannot bear. This speed. Then what will happen? Then our
bond will break.
then our intermolecular bonds starts to break. Now our intermolecular bonds, that means our holding hands starts to break. So if intermolecular bonds break, then that process requires energy. Suppose okay. Now suppose these intermolecular bonds starts to break. These intermolecular bonds start to break. So if they start to break, definitely they require energy. They require heat energy. They require heat energy to break this bond. Therefore, once this point is reached, this applied heat is utilized to break these bonds. This applied heat is totally utilized to break this bond. So once this point is reached, please listen to this very carefully. This is very important. Okay. Once this point is reached, the supplied heat totally utilized to break those intermolecular bonds. So the supplied heat is not utilized to increase kinetic energy. So after this point, the kinetic energy remains constant, but heat is supplied. The object is absorb heat. The object absorb heat, but kinetic energy remains constant because this absorbed heat is used to break those intermolecular bonds. Therefore, at this point, the supplied heat is totally utilized to break the intermolecular bonds. Therefore, kinetic energy remains constant. Now you know kinetic energy. If kinetic energy remains constant, that means after this point, the temperature remains constant, because temperature depends on kinetic energy. If kinetic energy constant, temperature also constant. Okay. Therefore, this heat is called as latent heat. In Sinhala, we call it as Gupta Tape. Why? We cannot see this increment of temperature. Gupta. The heat is absorbed. Vibration means what happened? Vibration means the heat energy, supplied heat energy. Okay. Therefore, vibration means supply heat energy. No other than. Okay. I will explain that thing again. Okay. Okay. Everyone, please listen to me. This is so important. Okay. Suppose again the same example. So suppose now I'm vibrating my two hands. Okay. So once the maximum speed is reached, that means the maximum speed that I can bear is reached, then what will happen? Then I cannot bear that speed. Then what will happen? The intermolecular bonds between us start to break. So the same thing happened in intermolecular bonds. Okay. So once we supply heat to this object, the vibration of this object increase. The vibrations increases. So as the vibration increase, there will be some point these intermolecular bonds cannot bear this vibration. So at that point, the intermolecular bonds start to break. So at that point, after that point, so if the intermolecular bonds start to break, that means it requires energy. So after that point, the supplied heat. The supplied heat is used to break these bonds, to break these bonds. To break these bonds. Okay. Did you get my point? After this point, the supplied heat is used to break these bonds. So initially, the supplied heat is used to increase of kinetic energy. Okay? Initially, the supplied heat is used to increase of kinetic energy. But once this point is reached, the supplied heat is used to break these bonds. Therefore, after this point, the supplied heat is not utilized to increase kinetic energy. Therefore, kinetic energy remains constant. But supplied heat is used to break those bonds. Due to breaking these bonds, what will happen? The state of that matter will be changed. That means if it is a solid, if it was a solid, it will become a liquid. If it was a liquid, it will become a gas. So at this point, there will be a change in state, change of state. So at a change of state, the supplied heat totally utilized to break the intermolecular bonds. Therefore, during that phase change, the supplied heat is not utilized to change of kinetic energy. Therefore, during a phase change or during a change of state, the temperature won't be increased because kinetic energy, temperature depends on kinetic energy. Now kinetic energy remains constant. Therefore, during a phase change, temperature remains as a constant. Okay, but the object receives heat. That heat is utilized to break intermolecular bonds. Did you get my point, everyone? Miriam? Very later. I need responses from everyone. You? Very no. If you have any questions, you are free to ask, okay? Yanisha? Is true?
So that means when there's a state change, at that time the temperature is remain constant.
Remain constant. When there's a phase change, there won't be temperature increment. Okay, that's why we call it as a latent heat. The heat supply during this phase change is called as latent heat because there's no temperature increment during that period. Temperature remains constant. Until then, temperature increases. With supply heat, but during that stage, temperature remains as a constant. This is temperature. This is supply heat. So up to that point, temperature increases with supply heat, but at that point, so during the phase change, temperature remains constant because the supply heat totally utilized to break intermolecular bonds. totally utilized to break intermolecular bonds. Okay. Therefore, kinetic energy remains constant because kinetic energy won't change, because if kinetic energy needs to change, definitely the heat energy should be supplied. No? Okay? But now supplied heat energy is totally utilized to break intermolecular bonds. Therefore, kinetic energy won't be changed. Okay. So temperature depends on kinetic energy. Temperature depends on kinetic energy. So if kinetic energy remains constant, that means temperature remains constant. Did you get my point?
Yes, sir, understood. Thank you, sir.
Okay. So during a phase change, temperature remains constant. Normally, we call it as in Sinhala, Gupta Tape. Gupta Tape. Hamata halattati. Gupta Tape. Gupta means pain now. Not visible one. And so, because when we supply heat, if there's a temperature change, we can see the supply of that heat. No, we can see that thing. I was actually, we have discussed that thing, no? What is that thing? Temperature is a sensation. It is temperature is a sensation that depends on kinetic energy. So now you can understand me through that thing. So during the phase change, temperature remains a constant. Remains as a constant, no? So according to this observation, I will explain that. According to the observation, you can clearly understand temperature depends on kinetic energy, you know. So I will explain that thing. When you supply heat to an object, the first thing happens is increment of its kinetic energy. You can simply understand using this example. Shaking vibration of our hand. Okay. So the first thing is increment of our speed. Okay. Although there is a increment in speed, still we can hold our hands. Up to some extent. But after that extent, what will happen? The intermolecular bonds start to break. Okay. So up to that extent, we can bear the vibration. That means what will happen? Up to that extent, the kinetic energy will be increased. But nothing happened to intermolecular bonds. Up to that extent, up to that point. Okay. Therefore, up to that level, the supply heat is totally utilized to increase kinetic energy of particles. Okay. Once you give heat, a heat to particles, suppose you are given heat to this object. You are given heat to this object using some candle or something. You are given heat to this object. Then what can you feel? You can feel an increment of temperature. No? You can feel an increment of temperature. That means the increment of kinetic energy can be sensed as an increment of temperature. Therefore, we define the temperature as a sensation that depends on kinetic energy. Okay. Did you get my point?
Yes, sir.
History? Other? Okay. Now we can write this thing. Okay. Okay, write the topic. Write the topic. What happens? What happens? What happens when heat is supplied to an object? Please listen to me very carefully. When you are writing this sentence, please read that thing. Okay. When you are writing these sentences, please read that thing. If you have any things to clear, please ask me. So this is the core part of the heat. So you are free to ask anything. So you are free to ask anything. Okay. No, you can write the topic again. Write the topic again. That's better. I will give from the beginning. Okay. Okay. Write down under a new under a new paragraph. As mentioned earlier, when heat is supplied to an object, as mentioned earlier, comma, when heat is supplied or given to an object, the vibrational kinetic energy of particles increase. Within the bracket at the beginning of that. Within the bracket at the beginning. Close the bracket. Since the temperature depends on kinetic energy, since the temperature depends on kinetic energy, an increase of temperature, an increase of temperature, an increase of temperature, an increase in temperature, an increase in temperature, an increase in temperature can be observed, can be observed, can be observed during this period, during this period. Okay. Once you write that thing, finish writing. Please read the sentence. Please read the sentence. If you understood very well, please give me a thumb. Thank you. Thank you, thank you, thank you. 5. Only 5. Okay. Repeat it again, miss. From which part, Puta? From the beginning.
Since the temperature
Since the temperature depends on kinetic energy, since the temperature depends on kinetic energy, an increment, an increase in temperature, an increase in temperature, an increase in temperature can be observed, can be observed, observed during this period, during this period.
what is
Sorry, Buddha? Okay. Hi. This is the first paragraph. I think you can understand the paragraph. Okay. Right? The second one. Second part. Logic. Sorry. Now we are building some logic. Okay. That's why I asked you to read the first paragraph. This is the first logic. Now the second logic or argument. This is the conclusion of first topic, the conclusion of first argument. We can write that thing. Therefore, this is the conclusion. Therefore, when heat is applied to an object, an increase in temperature, can be observed first. Can be observed first. Next paragraph. On further supply of heat, on further supply of heat, on further supply of heat, comma, on further supply of heat, comma, particles vibrate, more and more, particle vibrate more and more. Thus the temperature gradually increases. More and more. Thus the temperature gradually increases. Although the particles vibrate, comma, there is no significant change. There is no significant change in potential energy as they are bound by intermolecular bonds. As they are bound by intermolecular bonds.
Sorry, sir, can
From which part, Puja?
there is no significant change in potential energy.
There is no significant change in potential energy as they are bound by intermolecular bonds. Intermolecular bonds. First and second for up to mechanics. Up to mechanics. Sorry. But as the vibration increases, there comes a point as the vibration increases, there comes a point where no there comes a point where it is no longer possible. It is no longer possible is no longer possible to hold the particles together. The particles together to hold the particles together by intermolecular bonds. Intermolecular bonds. That is our second argument. Ready, tell me. Can you understand or not? If you can understand that, may argue, please let me know. Yes, very good. Thank you. Thank you. Others? Hari? Okay. Thank you. Yanusha? Meet? Okay. Thank you. History? Thank you. Hi. Then, the next paragraph. The next paragraph. At this point, at this point, at this point, the intermolecular bonds, I and B, sorry, intermolecular bonds start to break down, start to break down, start to break down.
Sir, can you repeat?
At this point, the intermolecular bonds, I and B, start to break down, start to break down. Because they cannot bear the vibration, therefore they start to break down. Okay. Initially, the provided heat energy, is completely used, is completely used to increase the kinetic energy, Okay. So up to that point, the supplied heat energy at the beginning is equal to increase of kinetic energy, of inner particle. Inner particles. Okay. Therefore, up to this point, the supplied heat is equal to increase of kinetic energy of inner particle by this equation now. Okay. Okay, right on this. But after this point, after this point, the thermal energy provided, the thermal energy provided the thermal energy provided is completely used, is completely used to break intermolecular bonds, to break intermolecular bonds. Therefore, at this point, the supply heat energy is equal to the energy required to break intermolecular bonds. Okay. Read that paragraph and tell me, do you have anything to clear? Please read the paragraph again now. Very good. Thank you, Vijay. Okay. Now, I need paragraph. Therefore, the thermal energy, therefore, the thermal energy provided at that time, the thermal energy provided at that time does not change, the vibrational kinetic energy, vibrational kinetic energy vibrational kinetic energy of the particles. Therefore, vibrational kinetic energy of the particle, of the particles. Therefore, after this point, therefore, after this point, only the potential energy changes. Only the potential energy changes. Temperature depends on kinetic energy. Temperature depends on kinetic energy. Therefore, if the kinetic energy remains unchanged, if the kinetic energy remains unchanged, the temperature won't be changed to okay. That means temperature depends on kinetic energy. It depends on kinetic energy. So if kinetic energy is a constant, then we can say temperature is a constant. Temperature is a constant. Therefore, no change in temperature. Therefore, no change in temperature during this period. Okay. I'll do this. Once you finish writing, please read that paragraph 2 and let me know if there is any problematic area. Correct. Write in another paragraph. Therefore, even if thermal energy is obtained at this time, no change in temperature can be observed. No change in temperature can be observed. This heat energy this heat energy that is supplied to break intermolecular bonds, is called latent heat. Latent heat. Latent heat. Latent heat. As there is no temperature rise, even if thermal energy is supplied. Even if thermal energy is supplied. Even if thermal energy is supplied. Okay. Read it. Read it. තේරුණාද? Thank you. Others? Thank you. Okay. මම අර වචනෙන් වචනේ අහන්නේ කියන පොඩ්ඩ අහන්නේ මේක තමයි පුතේ මේ තනි කරම හීට් ලෙසන් එකේ කෝ එක මම හැමදේම කිව්වේ මේක හරියට අන්ඩර්ස්ටෑන්ඩ් කරගන්න පුළුවන් නම් මේක ඇප්ලයි කරන්න පුළුවන් ඕනෙම අර මොනවද මේ හියුමිඩිටි කතන්දරේ කරෙන්න අනිත් ඒවා අපිට theory part එක මේ තේරුම් ගන්න මේක අපිට යූස් කරන්න පුළුවන් මේ concept එක. ඉතින් මේ concept එක හරියටම ඔලුව දාගන්න. අතිශය වැදගත්. කාට හරි මොකක් හරි මිස්ුණා නම් රෙකෝඩින් එක ආයි බලලා හරි මේ concept එක හරියට ඔලුව දාගන්න. එච්චරයි. හරි. හරි. Okay. Okay. Write down in a new paragraph. Once the intermolecular bonds once the intermolecular bonds break, there will be a change of state. Change of state. That means a solid will be converted into a liquid. Converted into a liquid. Or a liquid will be converted into a gas. So this is the most important part. Therefore, write down. I'm in a separate paragraph. Therefore, 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 yes, it's another one. අපි ඔක්කොම කියන්න පුළුවන්. Therefore, during a change of heat, the change of state during a change of state there is no temperature change. There's no temperature change during a change of state. Although there is although there is no any temperature changes, actually it's required to have very huge heat energy because there are a lot of intermolecular bonds to be break. Therefore, it's required a lot of heat energy during this period. But temperature remains constant. That heat energy is required to break intermolecular bonds. Therefore, generally, the latent heat means heat energy obtained by an object during a phase change is called as latent heat. Okay, so the magnitude of latent heat is relatively high because it involves huge heat energy. Okay, but no temperature changes. write down. But it involves a huge thermal energy to break intermolecular bonds. I will repeat it again. Therefore, it involves huge thermal energy to break intermolecular bonds. Therefore, the magnitude of latent heat, is relatively high value. Is relatively high value. Okay. Read the paragraph again and tell me if there's any unclear points. No, Uta, not all the bonds are broken. Okay, not all the bonds. Suppose okay. Suppose there are 1, 2, 3, 4. There are 9 particles in this material. 9 particles means something like 9%. Okay. Okay. Once we yes. I will come to that point. Okay. If it is solid to liquid phase change, it will be the melting point. That may constant temperature. Okay. If it is sorry. If it is a liquid to gas conversion, it will that constant temperature will be the boiling point. Okay. No. No, I will explain that thing to that. Not all the intermolecular bonds are broken, okay? Not all the intermolecular bonds are broken, okay? Because there can be some strong humans, strong person, no? That can bear the vibration, no? Suppose once the vibration is increased, once the vibration is increased, I cannot bear that one. I cannot bear that vibration. Because I am not strong. But there may be some person, he can bear that vibration because he is strong. Okay. So likewise, not all the bonds are broken. Not all the bonds are broken. Some bonds are broken. Some bonds are broken. Okay. Due to this broken bonds, then the solid becomes to liquid. Solid becomes to be liquid. When solid becomes liquid, not all the bonds are broken. Okay. But when liquid becomes a gas, then all the bonds will be broken. Because in gas state, all the particles are free to move. Free to move means where the intermolecular bonds can be neglected. Okay. Therefore, from solid to liquid, when it comes to solid to liquid, not all the intermolecular bonds are broken. Some bonds will be broken. Okay. Therefore, the weaker bonds will be broken first. The weaker bonds will be broken first. Yes. That's the point. Weaker bonds will be broken first. Okay. Then it becomes then it becomes a liquid. Solid, from solid to a liquid. Okay. So if it is a liquid, in solid, there is a closed path state. Okay. Both can be happen. Both can be happen. Broken means some kind of completely broken or partially broken. Both can be happen. Okay. So when heat is supplied, what will happen? The first thing is temperature increment. So particles remain unchanged, but temperature increases when heat is supplied. When heat is supplied, temperature increases. Okay. But now this is a solid. Okay. Now this is a solid. Okay. But once it comes to a certain point, the increment of this vibration, the increase of vibration cannot be bared by some bonds. Okay. So those kind of weaker bonds start to break. Okay. Not all the bonds, but the weaker bonds will start to break. Then during this phase change, We continues to supply heat. We continues to supply heat, but that heat does not. That heat will not be used to increase kinetic energy. This heat is used to break these intermolecular bonds. Okay. Then, once the intermolecular bonds are broken, the solid state will become a liquid state. In liquid state, the particles are arranged something like this. Okay. Not all the bonds are broken. Not all the bonds are broken, but some bonds are broken. Some bonds are broken. Therefore, initially there are 9 bonds together, all together. But after breaking some intermolecular bonds, now they are in some free arrangement. Okay, but there are some intermolecular bonds, but some bonds are broken. Okay, did you get my point? Now it becomes a liquid. Clear now? Okay, thank you. What I was discussing about the amount of latent heat. No, actually, there's a very famous example. The heat of steam. The heat of steam. No, you know that you know the heat of steam is very huge. The heat of steam. Why? Why? What is the reason? What is the reason? Huh? Even though temperature doesn't change, the heat of steam is more dangerous. Why? Steam means it is a part, it is in the middle of some phase change, no? Liquid to gas phase change. So during that phase change, some heat energy is absorbed. Even though temperature is constant, heat energy is absorbed to break intermolecular bonds. Therefore, the energy of that phase is relatively high. Okay. That's why the energy of heat is relatively high. Okay. Did you get my point? So what is that? Now we can define latent heat. No, now we can define latent heat. So what is the latent heat, Puta? Latent heat is the heat. Latent heat is the heat which is absorbed by an object during a phase change. Latent heat is the heat that is absorbed or received by an object during a phase change. Okay. Okay. Write down the key. The latent heat. Latent heat. latent heat. Internal එකක් දෙන්න තමුතු කරානේ.
Excuse me, sir.
Okay.
Sir, this diagram should be drawn in the book. Or...
No. I will tell you. The latent heat. First, we have defined the thing. Latent heat is the heat. Latent heat is the heat latent heat is the heat that is absorbed, that is absorbed by an object during a change of state. During a change of state. Latent heat is the heat. Latent heat is the heat that is absorbed by an object during a change of state. Okay. When we supply heat to an object, the first thing happen is temperature increases as the kinetic energy increases. So during this period, the supplied heat is equal to the increase of kinetic energy, because during this period, potential energy remains unchanged because intermolecular bonds are not broken. Okay. But during this period, the received heat energy is totally used to break intermolecular bonds. Therefore, this heat is called as latent heat. Latent heat. It is called as latent heat. So if we supply the latent heat to this object becomes a liquid. Initially it was solid, now it becomes solid liquid. So during this phase change, kinetic energy is a constant, so as temperature. So as the temperature. Okay. Now there will be new phase. Now you can draw this diagram. Yes, yes. Draw this one. Okay. Can you feel this, man? Can you feel now? Now this is a very interesting field, okay? Very interesting field. The හිතන ගොඩක් දේවල් තියෙනවා. මොකද එකපාර ඔක්කොම කියලා දෙන්නත් බෑ. කියලා දෙන්න බෑනේ කියලා දෙන්න. විලාගුස් නෑනිත් එක ඒ වුණාන් අර තේරුම් ගන්න අමාරුනේ පුතේ මුලින් එකක්. පොඩ. තව ඔක්කොම කියලා දෙන්න ඕනේ. හරිද? එතකොට සමහර සංඛ්‍යා තියෙනවා තාම කියලා දෙන්න බැහැරි. හරිද? දැන් අර කලින් අහපු ප්‍රශ්නෙත් තමයි ඉතින් ඒ වගේ ඒවා තව කියලා දෙන්න බෑ. මොකද ඒවට එනකොට මේවා ටික මේවා ගැන ඕගොල්ලෝ එක්ස්පර්ටයිස් වෙන්න ඕනේ. හරිද? But this now you have a lot of questions. Now you have a lot of questions. That means this is interesting. Questions එනවා කියන උඩ අනිවාර්යෙන් ඔයගොල්ලෝ මේක මේ ඉන්වෙස්ටිගේට් කරන්න වෙනවා. හරි. ඒක හොඳයි. අතරම මගේ දත්තියේ ෆිසික්ස් වල පුතේ ෆිසික්ස් අතරම වල අර ෆිසික්ස් පටන් ගන්න හීට් වලින් වගේ තමයි. අපි සාමාන්‍ය මැකනික්ස් කිව්වත් පස්සේ ඊට පස්සේ වේව්ස් ගත්තොත් අතරම ගොඩාක් ඒවා මේ කන්වෙන්ෂනල් ෆිසික්ස් එක මැත්ස් වලට එක්ක යන ගොඩක් කන්වෙන්ෂනල් ෆිසික්ස් අත තමයි දෙනිකව වෙන්නේ. මේ කියන්නේ එතනදී ගොඩක් වෙලාවට එක ෆිසික්ස් තමයි ෆිසික්ස් තුනා වුණාට අර actually I forgot to give you an interval. Sorry for that part because you had a lot of questions. Therefore, actually, I forgot to give you an interval. So I can complete class at 10:15. After that, you can have a 15 minutes break. Okay. Our window. Okay. Do you have any questions? Do you have any questions? One more thing. Okay. If anyone can purchase this book, this is really good. Okay. This is really good. Objective physics. අතරම මේක බේස් කරලා තියෙන ඉන්දියන් එක්සෑම්ස් ටිකක්. නමුත් අපේ එක්සෑම් එකට ආපු ගොඩක් ක්වෙස්චන්ස් මේකේ තියෙනවා. හරිද? මම මේකෙන් උගව ගොඩක් ක්වෙස්චන්ස් දෙනවා. ඒවට කාටද මේක පර්චේස් කරන්න පුළුවන් නම් පර්චේස් කරන්න මම හිතන්නේ මේක 4000 ගානක් වෙන්නේ මම ගන්නකොට දැන් ඕන වැට් එකත් එක්ක පොඩ්ඩක් වැඩි වෙලා ඇති. සංසයි බුක් ෂොප්ස් වල තියෙනවා. ඔබ්ජෙක්ටිව් ෆිසික්ස් එක. මේක හાર્ඩ් කොපි එක. මම ඕගොල්ලන්ට කලින් කියලා ඇති මම අර Amazon එකෙන් පර්චේස් කරන්න පුළුවන් නම් මෙයාගේම තමයි. මේ මහේෂ්ඩියන් ડોક્ટર මහේෂ්ඩියන් කෙනෙක් කෙනාගේම පොතක් තියෙනවා ඒ මේ physics for NEET and AIIMS කියලා. ඒකත් මේ බේස් එක මේක වඩා මේ ක්වෙස්චන්ස් එක තමයි තියෙන්නේ. හැබැයි ඊට වඩා ක්වෙස්චන්ස් තියෙනවා ඒකේ. මේ පොතේ වඩා ක්වෙස්චන්ස් තියෙනවා. හැබැයි ඒකේ ඉන්නේ වොලියුම්ස් දෙකකින්. මේක තනි වොලියුම් එක යනවා අපේ ඔක්කොම මේ ලෙසන්ස් ටික තියෙනවා ලෙසන්ස් නැත්තේ මේකේ නැත්තේ එතන මොකක්ද එකක් හරි දෙයක් හරි නෑ ලෙසන්ස් ඒ අරින්න පුදුම ලෙසන්ස් ඔක්කොම ටික මේකේ තියෙනවා. මේ අරගේ එන්නේ අපිට මේ Kindle version එකෙන් purchase කරොත් volumes දෙකක් තියෙනවා. volumes දෙක Amazon එකෙන් purchase කරනවා නම් මම recommend කරන්නේ Kindle version එකට යන්න කියලා. hard copies ගෙන්න ගන්න try කරන්න එපා. මොකද hard copies ලංකාවට එනවා කියන්නේ අපි දන්නේ නැහැ ඊද නැද්ද කියලා. අන්තිමට ඕගොල්ලෝ මේ order කරලා මේ සල්ලිත් ගෙවලා අන්තිමට එන්න තියෙන්න පුළුවන් පොත. ඊට වඩා ලේසි Kindle version එක ගන්නවා නම් Kindle version එක මම ගන්න කාලේ ඒක පොඩ්ඩක් ගන්න ඒක 12000 ගණනක් වුණා මම හිතන්නේ මේ එක වොලියුම් එකක් මේක වොලියුම්ස් ඔක්කොම ටික තියෙනවා හැබැයි මේක අර ප්‍රයිස් එක වෙන්නේ මේක ඇති මම නම් හිතන්නේ ඉතින් ඕගොල්ලන්ට මොකද ඉංග්‍රීසි මීඩියම් මේ පොත් නෑ උතේ හරිද ඔව් ඒ පස්සේ තමයි එන්නේ ඒත් ඒ දිග ෂුවර් නෑ නේද ඒත් ඒ අපේ පෝස්ටල් එකේ ෂුවර් නෑ ඒ තරම් අයියලා ඉන්නේ ඔක කල්ලා බැලුවොත් ඒ කල්ලා බැලුවට පස්සේ ආයෙව නෑ ඒකට හරි ඒ නිසා පුළුවන් නම් මේක පර්චේස් කරන්න පුළුවන් කරන්න මේකේ අම්මලා තාත්තලා දෙන්න එපා මේ පුළුවන් කට්ටිය ඉන්නවා නම් පර්චේස් කරන්න මේක මේ සරසවි බුක් ෂොප්ස් වල තියෙනවා අනිත් ඒවාත් ඇති මම ගත්ත එකෙන් මොකද්ද මේකේ ඕගොල්ලන්ට ඕනේ යුනිට්ස් ටික තියෙන ඔක්කොම ටික මේක ක්වෙස්චන්ස් ටික ඔන් කරගෙන ඇති මම මේක පෙන්නනවා මේක ඇවිල්ලා තියෙන ක්වෙස්චන්ස් ගොඩක් කියලා දීලා එක්සෑම් වල ආපු ක්වෙස්චන්ස් හරිද එහෙමම ආපු ක්වෙස්චන්ස් තියෙනවා ඊළඟට මොනවද වෙනස් කරලා ආපු ක්වෙස්චන්ස් තියෙනවා මේ ඒක නිසා ගොඩක් වෙලාවට ඔයගොල්ලෝ යූස් කරනවා නම් ෆොරින් එක්සෑම්ස් වලට ගහමු පොත් අපිට හරියන පොත් යූස් කරනවා නම් ගොඩාක් වෙලාවට ඒ ප්‍රශ්නම කරකිනවා හරිද මම ගොඩක් වෙලාවට දෙනවා නමුත් ඉතින් ඔක්කොම ටික දෙන්න බෑනේ ඒකයි මම ඕගොල්ලන්ට මේ පොත කිව්වේ මේ පුළුවන් නම් අරන් පර්චේස් කරලා වැඩේ කරන්න මම සිංගල් වීඩියෝ කට්ටියට කිව්වා මේක පර්චේස් කරලා පුළුවන් නම් මේ මම ඔය දැන් ඔය මේ පාර එක්සම් දෙන කට්ටියට මම කියන්නේ අනිවාර්යෙන් මේ දැන් අපි ඕගොල්ලෝ self revision and knowledge self revision කරනවා කියලා කියන්නේ පුතේ පරණ ඒවා අපි අමතක වෙන්න දෙන්න බෑ පොත පුතේ මහේෂ් ජේන් කියලා මහේෂ් ජේන් ડોક્ટર මහේෂ් ජේන් ඕකේ මම මේකේ ෆොටෝ එකක් දාන්න ගෲප් එකට මේ ස්චාන් කියලා කියන්නේ මෙතන මේ පබ්ලිෂර් ඌ තමයි මේ හැම වෙලේම ඔය පබ්ලිෂ් කරන අය ඉන්නේ. මැස්කන් කට්ටිය තියෙනවා මේකෙම මේ මෙයාගේ question banking mathematics කියලා. question banking mathematics කියලා පොතක්. ඒක ඒත් ස්චාන් කියන එකාගෙන තමයි. ඒ කියන්නේ එයා තමයි මම හිතන්නේ මෙතන. පබ්ලිෂර් වගේ ඉන්නේ. ඒකත් ගොඩක් හොඳයි. ඒකෙත් ගොඩක් questions ඇවිල්ලා තිබ්බා. ඒ පොතත් ගොඩක් හොඳයි. ඒ වගේ පොත් හොයාගන්න ඒක නම් හොයාගන්න නෑ ලංකාවේ. ඒක මම තව දැක්කේ නෑ මේ ලංකාව හොයාගන්න තියෙනවා. ඕක ඒක මට හම්බුනේ ඔය 1900 වරගණන් වල උත්වැයකකින් මේ ඊට පස්සේ ඒක හොයාගන්න නෑ කොහෙවත් හොයාගන්න නෑ. තාමත් දැන් මගේ එකට පොත සැරිවල් වෙලා තියෙන්නේ. ළමයිට දීලාම මේ සැරිවල් වෙලා තියෙන්නේ. මොකක්ද ඒක හොයාගන්න බෑ. ක්වෙස්චන් ඩාගේ මැතමැටික්ස් කියන එක පුළුවන් නම් බලන්න දැන් තියෙනවද දන්නේ නැහැ මම බලලා නැහැ දැන්. ඒකත් මාරම වටින පොතක් හැබැයි පියෝමට්ස් විතරයි තියෙන්නේ. මේක පුළුවන් නම් ඔය ටෙස්ට් කරන්න. Kindle version එක ගත්තත් අවුලක් නැහැ. ඒකට මම ඒකට පොතක් cost එක වැඩි හැබැයි. හරිද? මේක reasonable මොකද ડોક્ટર රෝසාගේ ඉංග්‍රීසි මීඩියම් පොතත් ඒත් 5000ක් වෙනවා ඊට වඩා මේක අඩුයි. හරිද? ડોક્ટર රෝසාගේ පොතේ අනිවාර්යෙන් ගන්න ඕනේ. ප්‍රොෆෙසර් රෝසාගේ. ඒක අනිවාර්යෙන් ගන්න ඕනේ. ඔයෙන් අරුවා ගන්න නැත්නම් වාගෙන මේ තමන් ස්කෑන් කරලා එවන්න මේ ඒක බව කරන්න ඕනේ. ඊළඟට කියන්නේ ඕගොල්ලන්ට දැන් ක්වික් රීකැප්ස් වලට මේ ගොඩක් කට්ටිය ඇටෙන්ඩ් වෙන්නේ නැහැ. හරිද? ගොඩක් කට්ටිය ඇටෙන්ඩ් වෙන්නේ නැහැ කියලා කියන්නේ සිංගල් මීඩියම් නේ ඔක්කොම කට්ටිය ඇටෙන්ඩ් වෙනවා. ඉංග්‍රීසි මීඩියම් ඇටෙන්ඩ් වෙනවා අඩුයි. හරිද? මම දැන් ක්වික් රීකැප් වලට ඇටෙන්ඩ් වෙච්ච කට්ටියට මම ඕනම ලිස්ට් එක දානවා. මට තේරුමක් නැහැ කියලා 20 මෙපා වෙලා තියෙන්නේ. තේරුමක් නැහැ කියන්නේ මොකද පුතේ ඕගොල්ලෝ මම නම් කියන්නේ අමතක වෙන්න දෙන්න යන්න එපා එක හැම. අනිවාර්යෙන් අමතක වෙන්න ගියොත් ඒක ඇත්තටම අපරාධයක්. හරිද? ඒ නිසා මම විශේෂයෙන් දැන් ඔය මේ පාර එක්සම් කරන ළමයිටත් මම කියන්නේ පරණය මතක් කරගන්න අනිවාර්යෙන් සබ්ජෙක්ට් තුනේම දවසට ක්වෙස්චන්ස් 5 ගානේ කරන්න. MCQ 5 ගානේ පුළුවන් නම් මම ඔක මේ දැන් ළමයින්ට නම් මම 10 ගානේ කරන්න කියනවා මොකද මේ දැන් ඕගොල්ලෝ ඉස්කෝලේ යන්නේ නැහැ. මොකද 25 කට්ටිය ගත්තොත් ඒ ඉස්කෝලේ නැති අපිට මේ ඒගොල්ලන්ට 10 ගානේ කරන්න වෙලාවක් නැති වෙයි. නමුත් 5 ගානේ හරි කරන්න. පරණ දවසට 5 ගානේ කරොත් දවස් කීයක් ඉද බලන්න. එතකොට ඒ දවස් ඔක්කොම යනකොට මොකද වෙන්නේ මේ කීයක් ක්වෙස්චන්ස් කළාද? හරිද? ඒක නිසා ඒකට නම් කම්මැලි වෙන්න එපා. දවසට ක්වෙස්චන්ස් දැන් 24 කට්ටිය නම් අනිවාර්යයෙන් දවසට ක්වෙස්චන්ස් 10ක්වත් එක සබ්ජෙක්ට් එකකින් කරන්න වෙනවා. දවසට ක්වෙස්චන්ස් 10ක් කියලා කියන්නේ ක්වෙස්චන්ස් 30යි. ක්වෙස්චන්ස් 30යි කියන්නේ පැයයි. හරිද? දවසට ක්වෙස්චන්ස් ඔක්කොම කරන්න ඕනේ නැහැ කියලා හිතන්නකො. මේ කියන්නේ සබ්ජෙක්ට් තුනම කරන්න ඕනේ නැහැ කියලා හිතන්නකො. නමුත් අඩුම ගන්න එක සබ්ජෙක්ට් එකකින් 10ක් කරන්න පුළුවන් වෙන පුළුවන්. හරිද? 10 කියලා කියන්නේ මේ ඔයගොල්ලන්ට යන්නේ 20 minutes. හරිද? 20 minutes දාන්න බැරි කමක් නැහැ. ඒක නිසා ඒකෙන් ඕගොල්ලන්ට පුළුවන් self recap එකක් දාගන්න. ඒ කියන්නේ ඕගොල්ලන්ට අර පරිකරම සබ්ජෙක්ට් එක අමතක නොවි තියාගන්න පුළුවන්. මම දැන් ඔය quick recap series එකේ මම දැක්ක එක කාරණයක් තමයි අර කොච්චර හොඳට ලකුණු ගත්තා වුණත් මේ කොච්චර හොඳට ලකුණු ගන්න පුළුවන් ළමයි වුණත් කරුණ දේවල් අමතක වෙලා තිබ්බා. කරුණ ගොඩක් දේවල් අමතක වෙලා තිබ්බා හොඳ ළමයිට. දක්ෂ ළමයිට. හරි. ඉතින් එතකොට තේරෙනවනේ දැන් මේක අමතකයි කියන්නේ. දැන් එතකොට ඕන සොලියුෂන් එකක් දෙන්න ඕන. එහෙනම් එතනට ගිහලා බලන්න. ඒක මම කියන්නේ මේ හැමෝටම මේකට මේ සහභාගී වෙන්න කියලා. මොකද ඔයාලගේ මට්ටම ඔයාලා බලාගන්න එක. මම ඔය ලකුණු පබ්ලිෂ් කරන්නේ නැහැ. මම පබ්ලිෂ් කරන්නෙත් නැත්තේ ඒකයි. මොකද මේ ළමයි කැමති නැති වෙන්න පුළුවන්. හරිද? හැබැයි මම එක්තරා අවස්ථාවක් කියලා මම ඉතින් පස්සේ පබ්ලිෂ් කරනවා. දැන් පබ්ලිෂ් කරන්නේ නැහැ. හරිද? මේ දැන් ඔයගොල්ලන්ට මේ හැදෙන්න දීලා තියෙන්නේ. හරිද? ඒ කාලය අරගෙන හැදෙන්න. එතනින් පස්සේ කට්ටියටම අර ෆ්ලක්චුවේට් වෙන මාර්ක් එන්නේ බෑ. අඩුම ගානේ කොන්ස්ටන්ට් මාර්ක් එකක් ගන්න ඕනේ. ඒ කියන්නේ more than 3 මේ 3 or more than 3 වගේ යනවා නම් ප්‍රශ්නයක් නැහැ. මොකද questions හැම වෙලේම පුළුවන්. ඒ කියන්නේ hard questions easy questions එන්න පුළුවන්. ඒවත් එක depend වෙනවා. ඒ නිසා more than 3 යන්න පුළුවන් නම් it's okay. හරි. හැබැයි constant weight එක හදා ගන්නවා. constant weight එක ඇතුලේ අර මේ ඕගොල්ලන්ට වලදේ questions තියෙන්න පුළුවන් hard questions විතරයි පුතේ. ඒ කියන්නේ අර theory අපි ඉගෙනගත්ත දේවල් අමතක වීම නිසා වලදේ questions තියෙන්න බෑ. තේරුණා? එහෙම වුණොත් අන්න ඒක තමයි ප්‍රශ්නේ. ඒකයි මම කියන්නේ හැමෝම ගිහිල්ලා අර ඒ recap questions ටික කරන්න. recap questions ටික කරනකොට ඕගොල්ලන්ට තේරෙනවා ඕගොල්ලෝ කොතනද ඉන්නේ කියලා. හරිද? නැතු ඕගොල්ලෝ දැන් හිතන් ඉන්නේ එක්සෑම් එකට ගිහලා ඕගොල්ලෝ ඉන්නවත් තත්ත්ව බලා ගන්නද? ඒක කරන්න බෑ. හරි. ඒක කරන්න බෑ. ඒක මම කියන්නේ හොඳට ඒක පොඩ්ඩක් තේරුම් ගන්න. හැමෝම ඔය එක්සෑම් එක ලියන්න සහ ඕගොල්ලන්ගේ ඉවලුෂන් එක ඕගොල්ලෝ කරගන්න. හරිද? මම ඒක කිව්ව මම අර සමහර විට ගොඩාක් හොඳට කරනවා. දැන් අර ගයිඩ් කරාට පස්සේ ගොඩක් හොඳට කරනවා තමයි ගොඩක් හිටියා. පොතක් අරගෙන වෙනම ක්වෙස්චන් එක ලියනවා. වෙනම ආන්සර් එක කප්පි විදි ලියනවා. ඒක මට ඒවල තිබ්බා. මට ඒක ගොඩක් කට්ටියට මම රිප්ලයි දෙන්නා. ඒ මට්ටමට ඉන්න කට්ටිය ඉන්නවා. එතකොට ඒගොල්ලෝ අනිවාර්යෙන් ඒගොල්ලන්ගේ අනිවාර්යෙන් ඒගොල්ලෝ මේ මිස්ටේක්ස් එක හදාගන්න. ඒක කියන්නේ අපි අඳුර ගන්න ඕනේ පුතේ. අපේ මිස්ටේක්ස් එක අඳුර ගන්න. මිස්ටේක්ස් එක අඳුරගෙන ටක්කා සොලියුෂන් එකක් දෙන්න. මොකද වෙලාවක් නැහැ. දැන් වෙලාවක් නැහැ. කියන්නේ දැන් මේ පාරෙන් ගැසට් එකක් ගහලා තියෙනවා මේ දෙසැම්බර් එක්සෑම් එක තියෙනවා 24 වල දෙසැම්බර් එක්සෑම් තියෙනවා කියලා කියන අනිවාර්යෙන් 25 සෙට් එකේ එක්සෑම් එක 25ම තියයි. හරිද? තිබ්බොත් මම කියන්නේ මේක තිබ්බොත් අරක තියයි කියලා මම කියන්නේ. අර මොනවද මන් දන්නේ නැහැ කියන්නේ අනිවාර්ය සම්බාධක කියලා වෙන්නේ මොකද දන්නේ කියලා. මේ වගේ තමයි දන්නේ නැහැ තිබ්බොත් තියයි. හරි? හැබැයි ඉතින් 25 කට්ටියට පොඩි chance එකක් තියෙනවා. මොකද මේ ඒගොල්ලන්ගේ semester එක තමයි කැලෙන්ඩර් එක පටන් ගත්තේ මේ පාර පෙබ්‍රවාරි. එතකොට first year එක ඉවර වෙන්නේ next year February. next year February කියලා කියන්නේ ඊළඟ 13 ඉවර වෙන්නේ ආයි ගොඩක් වෙලාවට 26ම වෙයි. ඒගොල්ලන්ට හරිද? හැබැයි ඉතින් 24 කට්ටිය පොඩි ප්‍රශ්නයක් තියෙනවා. එතකොට මේ ඩිසෙම්බර් තිබ්බොත් හරි දන්නේ නැහැ. හැබැයි ඉතින් සූදානම් වෙන්න හරි. හොඳයි. මම අද quick recap එකක් දැම්මේ නැහැ. හේතුව tomorrow and day after tomorrow you will have an exam. Okay? It is a full exam. Okay. Right. Do you have any questions up now? Do you have any questions up now? Okay. Now, look at this. Initially, there was a solid. Initially, there was a solid. What I was, sorry. Initially, there was a solid puta. Then, what I have done here, I have supplied heat to this solid object, no? We supply heat. Then, the first thing happen is, the temperature of this solid object is increased. Temperature increase. Then, after some point or after some time, then it comes to a certain point. At this point, temperature doesn't change. Temperature doesn't change. It's a constant. But still, the object absorbs heat. Still, the object absorbs heat. So during this point, during this period, due to this absorbed heat energy, these solid materials become a liquid. Sorry. Then it becomes a liquid. Okay. Then if I supply heat further, what will happen? Tell me what will happen.
Again, the heat increases.
Very good. Why?
because the kinetic energy,
Yeah.
there is movement.
Actually, Buddha, after converting solid into a liquid, now this is another material. Now this liquid acts as another material because the solid is totally converted into a liquid. Okay. Therefore, now intermolecular bonds are changed. The body strength are changed. Number of bonds are changed. Therefore, now this is totally another material. Okay, another material means actually another phase, but it attests another material. Therefore, once I supply heat to this material, now it is start to increase temperature as beginning. Okay. Now this phase is totally converted into a liquid. Now we have to consider the liquid phase. Now we have to consider the liquid phase. Liquid phase. Now, if I continually may supply heat into this liquid material, what will happen? What will happen? Temperature increases. Temperature increases. It attacks a separate material. Temperature increases. If I give heat into this liquid material, the temperature increases until it becomes a gas. Okay. Once I may supply heat to this liquid material, it absorbs heat up to some point. It absorbs heat up to some point. So up to some point, the temperature of this liquid material, increases up to some point. Okay. Up to which point? Up to which point? Up to another phase change. Then what will happen? What will happen?
The temperature is constant.
Yes. Then actually now there are some small amount of intermolecular bonds. Now those bonds will start to break. Those bonds start to break. Therefore, now the temperature is constant, but heat is absorbed. Heat is absorbed. Heat is absorbed. So heat is absorbed until all the intermolecular bonds are broken. Okay. Then the liquid phase, this liquid phase become a gas. Become a gas. Become gas. Okay. So during this phase change, temperature is constant. During this phase change, the temperature is constant until, and from here to here, temperature increases with the given heat, but during this phase change, temperature is constant. This constant temperature is called as
Melting point and
the
boiling.
melting point. It's called as the melting point. No, this constant temperature, Buddha, not the latent heat, not the heat. The temperature is called as the melting point. The melting point. Melting point. It is a melting point. Then when we supply heat to this liquid phase, the temperature of the liquid phase increases with the given heat. Okay. Then it comes to another phase change. Another phase change. That means liquid to gas. Liquid to gas. In liquid, there are some small amount of intermolecular bonds. So at this level, those bonds start to break. So the supplied heat is totally utilized to break those intermolecular bonds. Okay, so all the intermolecular bonds in this case, not all the intermolecular bonds are broken, but in this case, all the remaining intermolecular bonds will be broken. Okay, then it becomes a gas. Okay. So this constant temperature is called as the boiling point. The boiling point, very good. Okay, did you get that one?
Yes.
So if I draw the temperature, so the given heat versus temperature curve, this is heat energy. You want it? Measured in joule. This is temperature measured in Celsius or Kelvin. Okay. Okay. Then I don't know. There's a starting point here. So initially, when heat is applied to this solid material, what will happen? The supply heat is absorbed as a kinetic energy. The supply heat is used to increase its kinetic energy. Due to that reason, the temperature of that solid material increases. It increases up to some certain level, certain point. Then it comes to this point. That means the melting point. During the melting point, the object absorbs heat, but that heat is used to break intermolecular bonds. So that heat doesn't utilize to increase kinetic energy of that particles. Therefore, kinetic energy remains constant. Temperature depends on kinetic energy. Therefore, temperature also constant. Because I don't know the temperature of the solid material. No, it may be 30 Celsius, it may be 0 Celsius. So I cannot say what is the actual starting point. Okay? That's why I start from here. It may be the room temperature, but if it is a ice or if it is a water, it should be minus. No, because when it becomes to 0 Celsius, ice will become a liquid, no, water. Therefore, if it is a water, we have to start from minus temperature. Okay? So I don't know where we have to start, but suppose this is a solid material in the room temperature. Okay. And
Excuse me, sir.
yes,
So
ma'am.
is it uniform then?
Yeah, it is uniform. Then I will explain what is the reason. I will explain what is the reason. Okay. Okay. මේක මේකක් තියෙනවා. ඔයගොල්ලන්ට එන questions තියෙනවානේ. ඔයගොල්ලන්ට එන questions බැරි වෙලාවත් මම අර එවෙලේ answer එකක් දෙන්න බැරුව මම කිව්වොත් එimhe ඊළඟට explain කරනවා කියන තංකාලයක ඔයගොල්ලෝ ලියලා තියාගන්න. මොකද මට අමතක වුණත් ඔයගොල්ලෝ අහන්න ඕනේ ඊට පස්සේ. හරිද? තේරුණා? මොකද අපි සාමාන්‍ය මේ වගේ theory part එකක් කරනකොට ඔක්කොම එකපාර explain කරන්න බෑ. හේතුව ඊළඟ explanation එකේ ඉන්නේ ඊළඟ මේ session එකේ. මොකද ඔක්කොම එකපාර කියන්නේ කිව්වොත් තේරුම් කරගන්න බෑනේ. හරිද? ඊළඟ session එක තමයි ඊළඟ explanation එක දාලා තියෙන්නේ. එතකොට දැන් අද අහන ප්‍රශ්නෙට ඕගොල්ලන්ට answer එක දෙන්න වෙන්නේ මට ඊළඟ session එකේ. මොකද නැත්තම් ඕගොල්ලන්ට පිළිවෙලට යන්න බෑ. හරිද? ඒ නිසා ඒව note down කරලා තියාගන්න වෙනම ආයෙ අහන්න. හරි? Okay. Then sorry. Then during the melting point, the temperature is a constant. Temperature is a constant. Temperature is a constant. This is melting point. It's melting point. Now, so this phase is solid phase. This phase is solid phase. This is solid liquid interface. Solid liquid interface. Because there are some solid interface and liquid interface. Sorry. Solid liquid. Solid liquid. Both are opposite. Now, after that, the total solid materials are converted into a liquid. Then, now it is another material. Now it attaches another material. So once we supply heat to that material absorbs heat. Then, using that heat, the kinetic energy of that particle increases. That means they are moving or vibrating faster. Then the same thing will be happen. Once we supply heat to this material, but that means liquid phase, the kinetic energy of that particle increases. Then there will be a certain point that vibration cannot be bared by intermolecular bonds. So at that point, the intermolecular bonds start to break. Okay. So again, the same scenario will be happening. Okay. So once the intermolecular bonds start to break, the supply heat is fully utilized to break those bonds. So the supply heat doesn't go for the kinetic energy. Therefore, kinetic energy is a constant, remain unchanged during this period. Again, this is a latent heat. Again, this is a special point. Normally, we call it as boiling point. Initially, we call it as the melting point. So, after this liquid phase, again, temperature starts to increase. It starts to increase. Then again, there will be a constant level. That is called as boiling point. The boiling point. Okay. Now this is liquid phase. In this liquid phase, then this one liquid gas interface. Liquid gas interface. Okay. Then after converting all the liquid into gas, then there is another substrate. Then after if I supply heat further, the temperature of gas will be increased. Okay. So this is liquid solid interface. This is solid liquid interface. So this amount of heat is called as latent heat. Latent heat of fusion. Normally we'll call it as latent heat of fusion. This amount of heat is called as latent heat of vaporization. Did you get my point?
Yes.
Others? පාඩම් දෙකක තියරි ටික එකපාර කරේ. මොකද පරිකර ඔක්කොම ලොජිකලි එකට සම්බන්ධ නිසා. හරි. හරි. then ඔයාලට මේක අඳ ගන්න පුළුවන්. දැන් අඳගත්තට පස්සේ මම No. This is latent heat of not your word. This is latent heat of fusion. This is latent heat of vaporization. Vapor, vapor. Latent heat of vaporization. This is latent heat of fusion. Okay. හරි. මේක ඕනනම් මේ දැන් අඳගන්න වෙලාවක් නැත්නම් ස්ක්‍රීන්ෂොට් එකක් ගහගන්නකො. ස්ක්‍රීන්ෂොට් එකක් ගහගෙන ඊට පස්සේ ඉන්විසරේ අඳින්න. මම නෝට් එක දැන් දෙන්න වෙලාවක් නැහැ. හරි. ඔකේ පුතේ. question තියෙනවද? your exams. Your exam is 24 කට්ටියගේ 24 කට්ටියට මම පේපර් එකක් දෙනවා tomorrow. Like 24. Then 25 කට්ටියට day after tomorrow. But 25 Sinhala medium කට්ටියට tomorrow after 8:30. Okay. 25 English medium කට්ටියට day after tomorrow. Hi. Everyone, please look at the board. Do you have any questions regarding to this lesson? Do you have any questions? $25 English medium exam tomorrow. Tomorrow. 24 25 day after tomorrow. Right? Do you have any questions after now? My amount of please read the note again. If you have anything to clarify, please watch the recording again. Watch the recording again. But I prefer think a lot. That means you have to convert this knowledge into a your knowledge. මොකද මේක දැන් මගේ knowledge එකක්. මේක ඕගොල්ලන්ගේ knowledge එකක් කරගන්න ඕනේ. මේක තනියම බලලා ඕගොල්ලන්ගේ knowledge එකක් කරගන්න. හරිද? That is more important. So important. Okay. So it increases. There's no phase changes, no? Was the gas heat is supplied to gas, the temperature of gas increases. Okay. That's all. No. But there, if we consider gas, there are some certain considerations because when heat is increases, the pressure and volume will be changed. Okay, so when it comes to gas, it is complicated thing. Okay, but up to now, that explanation is enough. Okay. ඔයාලා දින ප්‍රෙෂර්ස් එක තියෙන ඔක්කොම ටික හීට් ලෙසන් එක දවස් ඔක්කොම ටික දැම්මොත් තමයි ඔක්කොම ටික ෂෝට් කට් වෙන්නේ ඒ තරම් ප්‍රෙෂර්ස් තියෙනවා. Very good. මම ආසයි ඒක. Okay. Okay. If you don't have any questions, we can complete today's class. If anyone want to take a screenshot, now you can take a screenshot, then you can draw these things in your book. Okay. Okay. Then we can come to today's class with that. Everyone, good night, everyone. I bought.
I was goodness. Thank you.
Come with that. I will say in English. I will say.
Okay, sir. Thank you, sir.